Okay, so let's talk about the basic properties of exponential functions. The domain of an exponential function is always all real numbers, which again, if you really like interval notation, you can write negative infinity to infinity. To find the range, we use the fact that any power of a positive number is always another positive number. So when we take a power of our base, we always get something that's greater than 0. What does that tell us then about the range of general exponential functions? Well, if our coefficient here is a positive number, and that includes 1, so that includes the case where there's no coefficient, well, our b to the cx minus h is always positive. Multiply both sides by a, and we have that a times b to the cx minus h is always positive, right? A times 0 is just 0. And then add k, and we get that a times b to the cx minus h plus k is always greater than, well, 0 plus k is k. So just doing some algebra with inequalities that we already know tells us that the range on our general exponential function with a positive is always going to be just the numbers greater than k in interval notation, k up to infinity. What if the coefficient is negative, right? What if a is negative? Well, that changes what happens at this step, right? At this step, we used that a was positive. If a is negative, we still have that our b to some power is always positive. But now when we multiply both sides by a, that reverses the inequality. And that happens because a is negative. And then we add k again, and we get that the value of our function is always less than k. Again, that coefficient being negative is what reversed that inequality. In the graph, we saw that when a was negative, the graph was upside down. Here we see that the value of the function is always less than that number k. Same fact. The range is all of the numbers less than k, so in interval notation, negative infinity up to k. K itself is not included. We never quite get to that asymptote. We can't get 0 by taking a power of something. Okay, so if we want to find the range and domain of some exponential function, the domain is easy. We can just write that down. That's always all real numbers. All we need to do is recognize that we have an exponential function. It's okay to plug any number in for our variable. As for the range, well, there are 3 ways we can approach this. We can just know this number is positive, so our k is 4, so our range is just going to be 4 up to infinity. Or we can do some algebra. 1/2 to the 2x minus 3 is always positive. So 4 times 1/2 to the 2x minus 3 is always positive. So 4 times 1/2 to the 2x minus 3 plus 4 is always greater than 4. Or we could imagine the graph. So this is just a quick sketch. We've got an x-axis and a y-axis. We have a horizontal asymptote at y equals 4, and then we're adding something to that, and this number is less than 1, so we're going to get close to the asymptote as we go off to the right. Our graph is going to look very roughly like that, probably a little bit more curved than I just drew it. So we live above the number 4, and that gives us the same range again. So any of those 3 ways of coming up with the range are absolutely correct. Just know off the top of your head what the range of an exponential looks like, or do a little bit of algebra, or think of the graph. Any of those 3 ways to find the range is fine. And then there's one other question we like to ask about functions, and that is, do they have an inverse? And thinking about those graphs pass the horizontal line test. An exponential function is always one-to-one. And we know that any one-to-one function has an inverse. However, none of the functions that we're already familiar with is an inverse of the exponential. We don't yet have a name for the inverse of an exponential function. We're going to learn one soon.